So, maybe next week pwede tayong mag-set up ng time for week 3 and 4 activities na available ako and si Jose. Maybe siguro class time din naman. I guess, ayun. So, yun ang naman magagawa ko. Bigyan kayo ng opportunity to consult ng live para instant yung feedback. Since, ayun, hindi naman pwede mag-set ng deadlines. That's not possible. So, I guess more opportunities na lang. Okay, share ko lang yung screen ko. Okay. Meron few slides prepared for this week. Konti lang naman. So yeah, as I've said dun sa Discord, ito yung agenda natin for today. So first is, I guess siguro sa mga nandito, okay na kayo dun sa first item. Pero for the benefit of those na hindi pa, I'll be or discussing or showing ano yung commonly nakikita mistake ni Jose doon sa proofs, lalo na with absolute values. So maybe additional information lang talaga siya for FYI in this case. Then a summary of yung mga past weeks. So basically, ano na dapat yung alam yung gawin by now? And ano yung dapat yung alam moving forward? Kasi basically yung first 4 weeks were yung starting point for the course. Since the course is about algorithms and data structures, and you can't really say anything about data structures or algorithms without knowing yung mga topics sa first 4 weeks. So, I guess pang 45 lang doon. Tapos, pag ba nag-on ako ng video, mas madami yung viewers. Okay. Try natin. So, ayan. And then yung problem set is released na. So a few things about the problem set. And then next is basically summary ng week 6 materials. So again, yung meeting na to is not yung primary resource nyo for the week 6. So mostly summary lang or skim through lang natin. So if hindi nyo pa nakita what to expect, if nakita nyo na ano dapat yung tinandaan nyo, and then lastly, an additional example na for the week 6 topic. So first is yung sa absolute value na maraming nagkaka-problem. So in essence, or typically, ang absolute value function, gusto natin tanggalin yung absolute value signs, di ba? Whenever we try to prove it, para kaya mo siyang i-combine with other things dun sa equation mo. So in order to do that, you use case-to-case na analysis or parang proving by cases. So yung first case, usually, pag positive si x, ang absolute value ni x is just x. So basically, walang modifications. But if x is negative or less than 0, the absolute value of x becomes negative x. So what if dagdagan ko yung nasa loob ng absolute value sign? So if dagdagan ko ba ito ng negative 1, itong nasa right-hand side ko, dagdagan ko lang din ba sila ng negative 1? So that's not really the case. Kasi si negative 1, nasa loob din siya ng absolute value. So what this thing above does is remove the absolute value for x. So it doesn't really affect, or it doesn't really apply, or kung may constant ako dito or another variable, hindi pwedeng si x lang yung galawin ko sa parang output or dun sa cases. So that is positively wrong. So ano dapat yung ilagay natin doon or saan sila equivalent talaga? So going back doon sa x minus 1, let's define x minus 1 to be another variable, let's say u. So this thing sa taas, magiging absolute value ni u, equal lang siya kay u if u is positive and negative u if u is negative. So if u is x minus 1, pwede natin i-replace x minus 1 dun sa u terms dito. So magiging x minus 1 and then negative of x minus 1. And then yung conditions natin dito, yung u kanina, magiging x minus 1. So basically, magiging x minus 1 sa taas. Yung sa baba is yung negation nung nasa loob ng absolute value sign. So the thing to note here is, yun, hindi lang si x yung na-affect or hindi lang si x yung ninenegate natin. Yung buong expression sa loob ng absolute value sign yung inenegate natin. And then for the cases, mag-iiba siya. It's not just x is positive, so x must be greater than 1 because we want x minus 1 to be positive. So, yung question now is, yung 1, pwede ko siyang palitan with any other number I want. Let's say a or maybe y. So, pag pinalitan ko siya ng a, ayun lang din, magpapalit lang yung 1 with the a. So, what if lagyan ko pa ng absolute value yung mga numbers sa loob? Ay magiging itsura nito. So, of course, hindi ko na siya sasabihin kasi that's giving way too much information. Pero hopefully this helps yung mga nahihirapan pa with week 3 exercises, which I think majority naman nakapagpasa na, but there are still a few or there are quite a significant number na hindi pa tapos. So, ayun. Maybe we can set up something next week para ma-address yun. So, next is summary ng past weeks na activities or materials. So, basically, for me, kaya kong i-summarize into 2 parts yung first 4 weeks. Siyempre, yung week 1 naman is just a review. So, basically, it's just siyempre, hindi naman tayo makakapag-implement ng algorithms if hindi tayo makakapag-program. Or we can't really see what a program does or an algorithm does without having a program to run it. So, the next other weeks is focus sila on algorithm complexity and algorithm correctness. So, these are the 2 things we use to analyze an algorithm. So, yung complexity mostly means or mostly tells paano nagre-react yung algorithm natin whenever the input increases. So this is usually related to yung running time or yung resources na ginagamit ng ating algorithm. So basically, yung summary ko for them is, yung sa complexity is just counting iterations ng loops or iterations on loops, loop iterations, I guess. So, how many times does a loop execute? So, hindi naman siya always dependent sa n. Let's say, yung condition mo nung while loop is something different. You need to figure out how many times does it run or how many times does it iterate given the input. Then sa algorithm correctness naman, in summary, it's just finding and proving a loop invariant. Of course, medyo hindi siya ganun kadaling gawin, lalo na yung pag-find ng loop invariant. Pero ang main hint or yung main way to do it is have some insight kung ano yung goal gawin nung iyong algorithm. So, For example, here sa, I guess sa selection sort, may two loops ka na tinitingnan. Yung inner na loop dito goes through each elements and finds the minimum. So, as the name suggests, a good loop invariant for this is, or I mean, going back, ano ba yung ginagawa ng selection sort? So, ang selection sort is basically selecting yung uh, yung element doon sa current index na tinitignan niya. So, starting with index 0, hahanapin ko kung aling element ba doon sa list ko yung ilalagay ko sa index 0. And in this case, siya yung minimum na number if we're ascending from lowest to highest. So, yung inner for loop mo should have something to do with finding yung minimum value here doon sa list mo. So, and yun, pwede mong sabihin, yung nag-iterate tayo for each element. And then meron tayong current minimum na sinostore. So, yung current minimum ko dito, let's say ngayon, 3. Ang masasabi ko sa kanya, lahat ng mga nadaanan kong element sa kanya is greater than 3. So, therefore, I can say na a possible loop invariant here is yung current minimum, as the name suggests, is the current minimum doon sa mga chinek ko na items. So, once nakapunta siya kay 2, si 2 na yung bagong minimum do sa current items. So, sa next iteration ng loop, si 2 na yung current minimum ko kasi siya yung pinakamaliit sa lahat ng nadaanan ko. And then, yun. So, basically, we formulate a loop invariant with the termination in mind. So, pwedeng yung pag-formulate mo ng loop invariant, meron kang mga assumptions, meron kang mga ina-assume or meron kang kino-considers. And then, when you actually prove it, dun mo kasi makikita kung exactly tama ba yung loop invariant mo. So basically, when you find the loop invariant, you're already halfway there. Kasi yung proving, if it already made sense nung finind mo siya, yung proving will just be parang sort of formalizing na lang kung ano yung reasoning mo behind doon sa paggamit mo ng loop invariant. So, yun ang masasabi ko for that. So, it really so, yun. So, sa mga nandito, I think yung iba sa inyo nakapag-submit na for week 4. So, ako yung mag-check nun. So, unfortunately, hindi pa ako nakahanap ng time para mag-check. Hopefully by Monday, meron na akong, or maybe later, tingnan ko, if makapagbigay na ako ng feedback dun sa mga submissions. Pero yun nga, I can't really say, or I mean, walang single way to give hints or give guidelines sa loop invariants kasi depende siya sa paano mo ina-approach yung paghahanap ng loop invariant. Pero yun nga, ang pinaka-straightforward na approach is looking into ano yung gusto mong terminating condition and then working your way backwards to basically, kung ano yun nga, gusto ko makuha yung minimum doon sa buong list ko. So, yung for loop mo will do that incrementally. So, since hindi pa ako sure kung si 2 nga ba yung minimum doon sa buong list, pero sure ako sa lahat ng chinek ko, 2 na yung minimum. So, parang smaller form siya noong terminating condition ko. So, yun. Next is yung problem set. Released na ang parts 1, 2, and 3. Fortunately, yung gumagawa ng week 4, medyo hindi masyadong responsive. Pero, ang ginawa naman namin, ang part 1 ng problem set is focused on complexity analysis. Gusto niyo siyang silipin. Part 1 is, ito, yung first is analysis of Python code. So basically, just checking if you're still familiar with the syntax. And then yung next is time complexity na. And then, actually to, time complexity pa rin siya. Complexity pa rin siya. So basically, time complexity of algorithms na given dyan. Then, for problem set part 2, this will be mostly on correctness. So basically yun, you just need to prove or ayun, what does the function do? Kung gusto nyo, i-type in nyo yung program sa inyong compiler and then tingnan nyo yung result. So that is usually a good place to start. Pero okay lang, kahit hindi nyo muna sagutin yung number 1, sometimes pwede ka nang mag-skip to number 2. Pero mahirap, yun nga, if hindi ka familiar kung ano yung ginagawa ng function, usually hindi ka makakaisip ng loop invariant. So, another tip, pwede kang, for example, may guess ka nung what does the function do. And then, you made the loop invariant for it. And then, turns out, hindi mo siya ma-prove. So, most likely than not, baka mali yung loop invariant or mali yung tansya mo noong ginagawa ng function. Maybe it does something similar, pero not exactly. So, ayan, it usually doon. So, ayun lang, don't be afraid of making a mistake and then redoing it again. I know it takes time, pero ayun nga, hindi naman parating tama on the first try. And then actually, yung part name is actually a hint, generic common function loop. So, bakit weird yung pangalan? Maybe there's something there. And then, ito naman sa pangalawa, yun din, proving the loop. Yeah, basically yun din. So yun, yung sort of hint na to, it's related to sorting. So, ayun. That's for part 2. And then for part 3, mostly related sa week 6 actually. So, recursion and divide and conquer. So, yung first part ata mostly on, yeah, this one is more divide and conquer since, ayun. And then this one sa baba is more on recursion. So, ayun, hopefully, mukha na siyang familiar sa inyo if you've gone through the materials. So, since hindi pa kami kasi sure among us handlers kung paano namin siya checkan kasi for the past few weeks, ang nag-check ay yung section handler. Kaso merong notion na yung gumawa ng problem set, siya yung mag-check. So, kung makikita nyo, merong mga last names, yung name ng file. So, for example, ito, Ong. So, si Sir Darby Ong, yung gumawa ng part 3. And then, dito rin, may pangalan kanina. So, si Sir Briones yung gumawa ng part 2. May possible din kasi na sila yung mag-check. So, in that case, we really need you to submit before a deadline kasi medyo mahirap siya logistically for us to check if anytime na lang kayo magsasubmit. I mean, hindi rin kasi siya ganun kaikli like yung normal na exercises na pagka kasi you have to understand pag chine-check namin sila, we'd like to parang tuloy-tuloy kumbaga na lahat ng problem set checkan ko na kasi para hindi ko natandaan ulit yung answer key basically. Basically, it just makes us easier if you can submit before the deadline. So tentatively April 28th. It's before the reading break which starts at April 29. So not sure if kita yung calendar ko dito. Weirdly enough, ang reading break nyo starts on a Thursday and then ends on a Wednesday. So, ayun nga, with the if we set it at April 28, it might be too soon. So meron actually discussion din na i-move namin siya before the start of yung next week na may activities, which is May 10. So as you can see, nag-reading break from 29 to May 5, pero yung next na activities nyo is May 10 pa. So pwede namin siyang i-move hanggang siguro May 7, which is yung week before no. But anyway, you can always submit late, but you have to inform us in advance para so may consideration naman for those who can't really submit on time. Pero yun nga, sana majority sa inyo makapag-submit before the deadline. And then, ang tip ko sa inyo, try to finish one part per week. So, as sa nakita nyo naman, ang part 1 related siya sa week 1. Tapos yung part 2 related siya sa... Ay, yung part 1 related siya sa weeks 1 and 2. Si part 2 related siya kay weeks 3 and 4. And then si part 3 related siya kay week 6. And then eventually yung week 4 related siya kay week 7 and 8. So, ayun, if lalo na ngayon kung ginagawa nyo pa rin yung weeks 1 and 2 or 3 and 4, pwede nyo nang isabay yung problem set para parang may continuity. And then when you finish week 6, tsaka nyo gawin yung part 3. And then when you finish week 7 and 8, gawin nyo yung part 4. So, ayun, lalo na if i-move namin yung deadline to around start first week na May, you can submit early. And then we're still, yun nga, depende sa checker. If ever kami ulit ni Jose yung mag-check, I will allow resubmissions if makapag-submit kayo ng maaga. Or, ayun, basically kung gusto nyo mag-submit ng late, sabihin nyo lang ahead. Hindi, not unlike yung sa exercises where okay lang if hindi kayo makasubmit agad, we're still assuming na magsasubmit kayo. For the problem set, if hindi kayo makapagsabi na magsasubmit kayo ng late, we'll assume na hindi kayo makapag or hindi ayaw nyo siyang gawin. Well, in that case, basically sabihin nyo if malilate kayo. Ayan, so now to actual week 6. So, yung week 6, ako yung nag-prepare ng materials. Kaya, ayan, iba yung itsura ng study guide. Based kasi sa feedback nung hinandle ko last sem, mas gusto nila yung style na ganito. So basically, may introduction and then yung outcomes. Instead of just bombarding you with links, meron akong konting summary dito nung kailangan yung malaman. And then, ayun, so link to a lecture notebook. So, imbis na slides. So that, actually, kahit wala kayo ng video, basahin nyo lang to. It should be enough. So, for week 6, it's on divide and conquer. Pero before going into that, we revisit recursion. And then put it in the context of our course, which is on algorithm analysis. So, ayun, may recursive function lang ako dito. And then, we analyze yung time complexity niya. So, yung main, I guess, yung pinaka-important when analyzing yung time complexity ng isang recursive function is yung recurrence relation. So, it's basically saying, yung time it takes for me, for the function to run with input n, paano ko siya i-define using itself? So in this case, sa factorial, since si factorial would require yung factorial of n minus 1, yung time it takes to get the factorial of n also takes the amount of time it takes. Also, yung time it takes for the factorial of n is composed of the time it takes to compute factorial of n minus 1 plus whatever else the recursive function is doing. So in this case, wala naman siya ibang ginagawa. Basic operations lang. comparison, multiplication. So that's just some constant. So, excuse me, the time it takes. So since recursive yung definition ng function, recursive din yung definition ng time niya. Now, we can't leave it like this kasi gusto nating ma-convert siya into a closed form na kaya natin applyan ng asymptotic analysis natin. So, may two methods dito kung titignan niyo sa table of contents, and actually may three total methods. Yung third method is specific to divide and conquer. So, for this one, ang first one is substitution. So, basically, itatry mong i-simplify, or syempre si t of n equals siya kay t of n minus 1 plus c. So, si t of n minus 1 plus c equals siya kay t of n minus 2 plus c. And then we can combine this. So, yung t of n ko is actually t of n minus 2 plus 2c. And then, going further, the more I subtract to n, the more c grows. And kung ano man yung sinusubtract ko kay n, siya yung coefficient ni c. So I can rewrite this as t of n is equal to t of n minus k plus k times c. So whichever yung isubtract ko kay k, siya yung coefficient ni constant term c. Now, di ba yung recurrence relation natin, ginamit lang natin so far si t of n equals t of n minus 1 plus c, which is yun yung ginamit nandito. So, ngayon, since we express it in this form, we actually know a value of t of n minus k. That's when n is less than or equal to 1. Or let's say equal to 1 in this case. So, if we evaluate, so if si n of k gawin kong 1, or ayun, if n equals 1 or k equals n minus 1, yung magiging nasa loob nung ito, basically, is magiging t of 1. And we actually know what t of 1 is. It's just a constant. Tapos, ayun, so since naging t of 1 siya, alam natin yung value ni k is n minus 1, yung coefficient ni c1 is magiging n minus 1. So, with this expression nung running time nung ating recursive na function, kaya natin siyang applyan ng asymptotic analysis. So, ang largest growing term dito is n. So, this function in particular is runs in linear time with respect to n. So, yung other method is yung recursion tree method. So, in this case, more graphical siya, pero actually it starts with the recurrence relation as well. So, ibang function naman to. So, si Fibonacci of n, ang running time ni Fibonacci of n is the running time of Fibonacci of n minus 1 plus yung running time ni Fibonacci of n minus 2. So, yung running time ni Fibonacci of n, si n minus 1 plus n minus 2 plus some constant. And then, so basically, since tinanggal na natin si n minus 1 at n minus 2, ang running time na lang nung Fibonacci of n is technically constant. And then, yun din yung case for yung running time ni Fibonacci of n minus 1 is yung running time ni n minus 2 plus n minus 3 plus a constant na natitira. So basically, kung constant lang naman lahat ng mga nodes na to, we just need to count yung number of nodes in total dito. So, kung papansinin nyo, for each level, let's say level 0 tong una, we have 2 to the 0 na nodes. So, at level 2, meron akong 2 to the 2 or 4. So, magkakaroon lang tayo ng konting parang, since asymptotic analysis, we can actually, basically sa last level, kahit dalawa lang sila dyan, you can say na 2 to the n pa rin yung number of items doon. So, yung the total runtime would be, ayun, less than yung summation per level. So yung first level is one constant, yung si level 0, one constant, level 1, 2 times constant, level 2, 4 times constant, sin level 3, 8 times constant. And i-add up ko lang naman yun. Actually, kahit hindi ko i-add up, if I would apply yung asymptotic na analysis, yung fastest growing term ko dito is 2 to the n minus 1. So, yung running time ng function na to is actually 2 to the n. So, big O yun, and actually it can be smaller since hindi naman 2 to the n minus 1 actually yung last term. I mean, hindi 2 to the n minus 1 yung dulo. But it's a good approximate na for the case of our discussion. Then, apart dun sa time complexity, what special or what something more to note about recursive function is that it uses auxiliary space. So, auxiliary space is yung additional na program memory na ginagamit natin. So, recall, whenever we call a function, memory is stored basically to remember na kinol natin si factorial of 5. So, whenever we call factorial of 5, call niya si factorial of 4. But our computer needs to remember na kinol siya ni factorial of 5. So, whenever we need to remember something, it consumes memory. So, basically what you can see here, since factorial of 5 will call factorial of 4 hanggang 1, it will use up to 5 times more memory compared to calling it just once. So, yung growth or yung space complexity natin in this case would be linear or O of n. So, sa factorial, kahit bilangin lang natin kung ilan yung function calls. Pero kung titingnan nyo for the Fibonacci na function, let's say Fibonacci of 5, pagdating natin kay 1, magre-return na tayo. And then magko-call siya ulit. And then magre-return, magko-call. Minsan magre-return agad. And notice that yung maximum space, hindi siya actually lalampas to a certain level. Kasi eventually, we stop going deeper doon sa ating recursion tree and akit na tayo. So, notice na parang isang branch lang naman yung nasa program stack at a time. Pag bumalik na tayo doon sa stack natin, nababawasan yung kailangan natin tandaan. So, what's more accurate is yung auxiliary space natin is more dependent on the level ng recursion tree or yung deepest level ng recursion tree or yung recursion depth. So, in this case, from level 0 to level n minus 1. So, ang space complexity ng Fibonacci is, ayan, O of n minus 1 or O of n. So, for future na recursive functions, usually it will follow the form na kung ano yung space ng isang function call. So in this case, medyo plain lang naman yung function natin. Wala siyang additional memory. So constant memory siya per call. And then multiply lang natin siya dun sa deepest level niya sa stack. So yun lang basically. I mean, yun yung simplest way of looking at it. Or this is a generalization, of course. And then this is assuming na yung space alone is constant for each level. So if ever different siya, mag-iiba yung maging summation yung itsura ng space complexity nyo. Much like yung analysis mo for time complexity. Now, since yun nga, we're analyzing complexity, we are also analyzing yung correctness ng isang recursive na function. Then similar to analyzing loops, may loop invariant. So for recursion, merong recursion paired. Yung recursion paired invariant na term, medyo gawa-gawa ko lang. Mas appropriate term is yung predicate, which is mas gamit sa references. So basically, yung loop invariant is something that is true for each loop iteration. yung recursion predicate is something true for each recursion level. So, for example, here, yung predicate ko is yung factorial of n is equal to the product from these boundaries times yung factorial of n minus k, where k is arbitrary integer, pero in this case, actually, much more appropriately, siya yung recursion depth. So, for example, when case is k equals 1, so that means isang function call pa lang yung ginawa ko. Yung factorial of n is equal to n times yung factorial of n minus 1, which is yung definition ng factorial function, n times factorial of n minus 1. So, through the inductive step, mapuprove mo na yung factorial of n minus k. Ayan. So, basically, mapuprove mo yung loop, yung predicate. And then at termination, yung deepest level is when k is equal to n minus 1. So, when k is equal to n minus 1, may factorial of 1 to. And then yung factorial function ko equal siya sa n times n minus 1 hanggang 2, hanggang times 2, hanggang times 1. So, which is yung expected na value natin out of the factorial function. So, yeah. So, basically, yun nga, to analyze the recursive algorithm, you need the recurrentialization, and then either use the substitution or recursion tree method to get the closed form expression to apply yung big O. And then nga, additional memory when using recursion. So next is yung divide and conquer. So divide and conquer is yung, ayan dito sa notebook. We have a problem, divide natin siya into smaller sub-problems, and then yung sub-problems yung isosolve natin, and then combine to solve the bigger problem. So, bakit related si recursion kay divide and conquer? Kasi yung big problem natin, split natin to sub-problems. And then yung sub-problems, paano natin siya isosolve? Divide and conquer din. And then yung smaller sub-problem, actually pwede natin isolve using divide and conquer pa rin. So you can usually define a divide and conquer algorithm to recursion. I mean, it's very, it will be very simple that way. So for example, dito sa search, if familiar kayo sa binary search, we first look at yung middle element, and then we either search yung left part or yung right part. So, ayun. So, yung binary search starting at the whole list, pwede ko siyang gawing binary search for the left one or dun sa right part. So, basically, of course, pwede mo itong i-implement in an iterative way. Pero, yun nga, pinakamadali yung divide and conquer when we use recursion. So, ayun. I'll leave this to you na lang since meron naman ako separate videos on this. Tapos, ayun. Another example is yung merge sort. And dito mas makita yung parang 3 key steps when we do divide and conquer. So, sa merge sort, ang una niyang gagawin, mas makita dito, is i-partition niya yung ating list, and then mag-merge siya. And then, since nag-merge siya ng mga sorted na list, madali lang i-maintain yung pagka-sort. So parang if meron kang dalawang increasing na list, pwede kang mag-alternate na kumuha, and sorted pa rin yung magiging result. So yun yung nangyayari dito. So, ayun, kung ano meron akong partition dito, paano ko ito isosolve? So, gagamitan ko rin siya ng merge sort. So, ito, meron akong dalawang one element na arrays. Since isang element lang yung array ko, sorted na siya. So whenever I have two sorted na arrays, madali lang silang i-merge to make a sorted na bigger array. So kung titingnan nyo yung code niya dito, kung titingnan nyo lang yung merge sort itself, basically kailangan ko lang gumawa ng partition, hahanapin ko yung gitna. And then apply ko lang si merge sort sa start, and then apply ko lang si merge sort. I mean, merge sort ko yung first half, merge sort ko yung second half, and then merge ko sila. So hindi ko na kailangan alalahanin kung paano na-sort yung dalawang partitions. Ang alam ko lang, since ang goal ni merge sort is i-sort yung dalawa, yung result niya, pwede ko nang i-assume na sorted na yung dalawa ko after kung i-call ito at saka ito. So when I merge them, may assumption na ako na yung two sub-arrays ko sorted na. So basically, mas madali na yung implementation ko since parang may additional information ako about the sub-arrays. So yung time complexity niya, yung merge operation actually takes linear time. And then yung merge sort ko on the whole array calls two merge sorts doon sa half niya. So 2 times t of n over 2. So ayun, you can use yung recursion tree for this. So tingnan nyo lang, as you can notice here, yung t of n, yung dalawang t of n over 2, ito na sila dalawa sa baba. So ang kailangan ko lang bilangin for merge sort n is yung n plus constant. So for this level, so first level, ang runtime ko, n plus constant. Yung next level ko, n plus twice ng constant, since may dalawa akong n over 2, in-add ko sila. And actually, you notice for each level, meron akong n plus kung 2 to the level plus c. So, n plus 2 to the I times c. So, summation lang naman. Summation, so simplification ng summation term. And then, yung 2 to the k, k is basically yung level natin, di ba? So, up to level k. And since we know at n equals 1, magiging constant yung t of n na term. I mean, ayan. So, alam natin at 1, then si 2 to the k magiging log of n. So, basically, kaya natin i-replace si k dito in terms of n, and meron na tayong big O in terms of n. So, actually, a merge sort has a running time of n log n, which is definitely better do sa mga na-discuss na n squared. So, yung space complexity niya is medyo complex kasi may dalawang function involved. So if titignan lang yung merge sort itself, actually log of n lang siya. So yun yung depth, and this is actually yung first term here. Kaso meron tayong merge function over here, and meron tayong temporary array na ginagamit dito. And then yung maximum size ng temporary array is proportional, linearly proportional doon sa size ni n. So, ang space complexity ni merge sort for this particular implementation is actually linear. So, we got a better sorting time for more memory. Then, lastly, for divide and conquer algorithms, since, yun nga, halos parati siyang 3 steps. You divide, and then you conquer, and then you merge. So, yun yung 3 main parts dito. Si B, yung number of partitions na ginagawa mo. Si A, yung number of partitions na kina-conquer mo. Yung magandang example doon is yung sa binary search. Gumagawa ka ng 2 partitions for binary search, pero you only search one of them. So, parang kina-conquer mo lang yung isa. So, hindi mo pinapansin yung other partition. So, 1 lang siya nun. So for binary search, and then yung other terms or yung merge, since si binary search, di naman talaga siya nagma-merge, constant operation lang siya. And then, ayan. So, magsisimplify siya to log of n, which is yung time complexity niya nga dito. So, consistent naman siya. So, if you apply it dun sa merge sort na recurrence relation, you should also get the same result. Now, yun yung sa divide and conquer. And actually, may summary ako nung master's theorem here. So, you'll have two exercises, quick sort, and then a short quiz. So, sa HackerRank, kita ba natin dito? Challenges, quick sort. Ayun, so, basically may template na kayo dito. And you actually have yung recursive calls. So, ang kailangan nyo lang gawin is gagawin mo yung partition. So, here, makikita nyo yung quick sort. Yung paggawa nyo ng partition is not as straightforward as merge sort. Kasi sa quick sort, yung dalawang partitions mo, ayan, tingnan natin sa next run. Mas kita siya doon. Ayan. So, in this case, si 38 yung pivot. Yung tinatawag natin pivot. And then, when we find the last, yung partitions natin, yung left partition ko, lahat less than the pivot. Yung right partition ko, lahat greater than the pivot. So, yung paggawa ng partition is actually yung medyo matrabaho for quick sort. And then, after nun, you'll be having a quiz sa UVLE. Okay. So, yun yung for week 6. And, medyo 1 hour na ako. So, I guess, kaya naman siguro this additional example. So, personally kasi nagamit ko yung approach nitong solution na to a programming interview when I tried looking for companies. So, I just thought na maganda siyang ipakita sa inyo. So, yeah, meron lang akong function dito na magpa-plot and then something na parang debug statements lang. So, something to run lang, parang utilities lang. Okay, so yung problem is meron akong array of numbers and gusto kong mahanap yung maximum na sub-array. So, for example, ito, meron akong array of digits. Ito yung buong array ko when I plot it out. And then, pag pinagsama-sama ko yung mga nandito, siya yung maximum na sum na makukuha ko out of so yung sub-array, which means a part of the array. So, hindi ako pwedeng pumili nung lahat ng maximum points. So, supposedly, dapat sunod-sunod sila. And then, pag in-add ko sila yung maximum na maximum na total. So, yung straightforward na approach is yung n-squared approach. Basically, itatry natin lahat ng starting element, lahat ng ending element, and then i-calculate yung sum nila. So, I'm not sure if may kita dito. Ayan, so meron kasi akong debug dito. Whenever I get the sum, so basically yung ginagawa ng function is chine-check ko yung sum ko from 0 to 0. And then, i-compare niya siya doon sa current na maximum. So, yung first try niya is 13. Since yung sinet kong initial na sum is some negative number, some large negative number, so obviously, siya na yung largest na sub-array, isang element at 13. So, ang gagawin lang nung algorithm na to is check ko lahat ng combination. So, from 0 to 1, 0 to 2, 0 to 4, 0 to 5, 0 to 15, hanggat walang lumalaki sa 13, hindi ko siya tatandaan. So, after kung i-check lahat ng from 0 to something, 1 to something naman, and then 2 to something, and then, yun, when I get from 3 to 3, nakakuha ko ng 20. So, that's a new maximum. So basically matagal kasi yun, aabot ka dun sa 15 to 15. Tapos, ayun, makukuha mo rin yung same result. Makukuha mo yung maximum na from, I think, 7 to 10. So, ito yun, 7 to 10, 43 yung maximum. So, analysis ng function. So, may dalawa akong loops. Yung inner loop ko is up to the length ng array. Yung outer loop ko is up to the length ng array. So, ang running time niya is O of n squared. So, what's actually interesting here is yung mga print statements ko is actually naka-debug statements or yung debug, dinefine ko dito. If gawin ko itong false, and then i-run ko to ulit, ayun, mawawala na yung text, yung actual output lang. So, baka lang makatulong if gusto nyo lang yung sagot or if gusto nyo ma-visualize yung step-by-step na nangyayari. So, ano yung divide and conquer approach natin? So, of course, sa divide and conquer approach, gagawa tayo ng partitions. So, let's say similar sa merge sort, i-partition natin siya into 2. So, we can start with this template na as long as more than one element yung array, magpa-partition tayo. Hanapin natin yung gitna. And then, I do the operation on the left subarray and then do the operation on the right subarray. And then, possibly do something else in the middle over here. And then, ayun. So, basically, doon tayo mag-start. So, what's next? So, kung ito yung buong array ko, and then, this one would find the maximum subarray dito sa left ko. And then this one would find the maximum subarray dito sa right ko. So, ayun. Alam ko na yung maximum sa left ko, alam ko na yung maximum sa right ko. So, ano pa yung natitirang possible na maximum sa buong list? So, that will be something na magkocross ng gitna. So, yun na lang yung kailangan ko pang alamin. So, parang ang ginamit kong terms dito is meron kang contender, parang merong sino ba yung mga possibly maximum subarray. So yung maximum subarray nung nasa kaliwa, yung maximum subarray nung nasa kanan, or yung maximum subarray na tumatawid sa gitna. So yun yung tatlong contenders. So ito medyo mahaba siya kasi naglagay ako ng debug statements. Pero pwede kayong mag-skip ng konti dito. Basically, yung first contender ko is maximum subarray to the left. Second contender, maximum subarray to the right. And then yung third contender ko is yung maximum subarray na tumatawid sa gitna. So ito yung maximum subarray na cross. And then basically, kino-compare ko lang yung mga C. As you can see, yung mga result kasi ng mga call is tuple siya. So yung first element is yung sum, second element yung start, third element yung end. So, ayun. If ever isang element lang siya, yung maximum subarray is the element itself. So, kaya yung maximum sum is just yung value niya. And then yung start and start, well, pareho lang kasi yung start. And then yung end ko dito is actually exclusive din siya, like sa merge sort. So, ayun. So, na-define ko na yung recursive call ko. So, yung kailangan na lang natin i-define is yung paano natin aalamin yung maximum na crossing subarray. So, since kailangan kasama yung middle element or kailangan nating tumawid dun sa gitna, kailangan meron tayong subarray sa kaliwa niya, meron tayong subarray sa kanan niya. And then, actually, yung key information dito is kailangan natin magsama ng tumatama sa middle na subarray. So, it's unlike yung first approach na wala tayong clue at all kung saan tayo maghahanap ng maximum na subarray. Kaya ito try natin lahat ng combinations. lahat ng combinations ng start and finish. And in this case, kailangan natin hanapin yung maximum sa left, yung maximum sa right, and then i-combine na lang natin sila. So we have the maximum na crossing. And then when we get yung maximum sa left, alam na natin kung saan siya matatapos. So linear na lang yung process for us kasi isa-isa na lang natin check yung mga nasa left. Hindi na natin kailangan palitan yung isang boundary. So whenever we do that is ganun lang. Ina-add lang natin to the left, isa-isa, and whichever is yung maximum na sub-array, yun yung isa-store. And then, same goes with sa right. Since alam natin na kailangan niya mag-start dito, yung kailangan ko na lang i-check is n over 2 items. In comparison dito, kailangan kong i-try lahat ng start, lahat ng end. So basically, by defining yung boundary natin, mas mabilis na yung algorithm natin. So when we run this, check na lang. So, kailangan ko muna itong and then, yeah. And so yung result niya naman is actually the same. And then if gawin ko lang through yung debug para makita niyo yung debug statements. So medyo mahaba siya, of course. Ayan, so magsa-start siya dito is yung getting yung maximum sum from 0 to 16. Gusto natin mag-operate on the left muna. So 0 to 8, 0 to 4, 0 to 2, hanggang maging isang element na lang yung partition. So si 0 to 2 minus 1, isang partition lang siya, ay isang element lang siya, so that's 13. So yung left contender natin sa ano na to is just 13. And then yung nasa right is one element, negative 3. So when we cross, that is, ayun, 13 plus 3, ay 13 plus negative 3. So that's 10. So comparing 10, negative 3, and 13, panalo si left contender natin, which is yung 13. So yung left contender naman ng sub-array na 0 to 4, ayun, meron na tayo nung left niya. Kukunin naman yung sa right. So 0 to 4 naman. So hopefully makita nyo yung pattern. Basically from the whole list, nag-start siya sa left dito, hinanap niya yung dito sa left, yung nasa katabi niya sa right, and then nahanap niya na yun dun sa buong left dito. And then gagawin niya rin yun dun sa nasa kanan, and then so basically mukha siyang merge sort, of course, kasi yun, divide and conquer algorithm siya, pero yun. So complexity analysis, ayun, so twice tayo nag-call itself over half the elements, and then yung time it takes for us to cross, or yun yung basically merge operation natin in this case. Kasi operate tayo sa kaliwa, and then yung combine, so parang merged. So yung time complexity in crossing is O of n. So similar to merge sort, ang time complexity niya is n log n. So you can apply yung master theorem or whichever method you want. So yung proof of correctness, medyo wordy lang siya. Basically, yung the way we formulated it is basically yung proof ng algorithm. So yung maximum subarray from start to end is yung maximum subarray nung between start to mid, mid to end, or yung crossing. And ayun, basically that will be true. Yeah, basically ito yung assumption natin sa start pa lang, kaya natin in-expect na gumana siya. So basically this is just the proof kung bakit siya totoo. So in this case, so sa start, ang base case natin is whenever end minus start is 1 or single element yung start to end. So whenever that happens, isang element lang. So yung start to mid, mid to end will actually be the same value. Well, depende kung paano ka nagpa-partition. One will be one element, one will be wala siyang laman, and then yung crossing mo, wala rin siyang laman kasi isang element lang. So for sure, siya yung maximum na subarray. So that is for the base case. Sa inductive step, ito na yung assumption. And then when you prove that MSA cross or yung maximum subarray na crossing, you can prove na siya yung naghahanap ng maximum subarray containing the middle of the list. So, since ayun, medyo exercise na siya for you kasi ang analysis naman niya is sort of linear naman na. I mean, hindi na siya recursive. So, loop invariant dito, loop invariant dito. And then, once you prove na yun nga, maximum subarray siya na nagko-cross, excuse me. And then, if you notice that if the maximum subarray does not contain the midpoint, it should be in this partition or in this partition. So, since we already know kung ano yung maximum subarrays per partition dito, we can already get yung maximum subarray nung buong thing. So, yeah. So, at the terminating condition, yung start at saka end values is yung buong array. So, we get yung maximum na subarray over the whole array na presented. So, yung analysis dito is arbitrary start and end. So, it doesn't mean yung start and end ng buong subarray. So, ayun. Yeah, so basically that's it for this example. Gawan ko siya ng snip and upload ko separately if gusto nyo siyang daanan without going through the whole video. So yeah, so that's basically it for this meeting. May mga questions ba? May mga participants pa ba? So hopefully this has been helpful kahit medyo minadali ko siya because of the time. Ayoko rin kasing mag-upload ng 1 hour or more than 1 hour na video. So medyo matagal din yun. So walang questions. So ayun. If ever may questions kayo after this, meron tayong forums, meron akong email, you can always email. And then, ayun. Yeah, maraming salamat sa pag-attend. Wala na talagang questions over there. So, maybe next week, to cater for those na medyo nahuhuli, maybe yung synchronous session will be focused on yung previous activities, medyo siguro. I'll see what I can do. So, maraming salamat and yun, lunch na tayo.